Hello everyone, in this tutorial I'm going to show you how to simulate an explosion on an underground pipeline. So in modeling section we're going to model 5 different parts, which is going to be air, soil, TNT, steel pipe, and also domain, which is going to be a Eulerian domain. For this tutorial we're going to have two models. One model, TNT, is going to locate it in the middle of the pipeline, and the other one in model 2, the TNT, is going to locate between the air and soil border. So half of it is on the air, half of it is in soil. What you're going to expect in the results section. So as you can see here, when the explosion happened inside the pipe, it's going to destroy a pipe and it's going to develop inside the soil slowly, and suddenly it's going to reach the air and it's going to develop faster. And in model 2, the explosion is going to happen in a border between the soil and air, and as you can see, the top part grows faster than the bottom part, which is obvious because the explosion wave can move faster in the air in comparison to the soil. And as you can see, when the explosion wave reaches the pipe, we're going to have a deformation here in the pipe. And also, as you can see here at the top part, the explosion wave leave our domain, which is 12 meter to 12 meter. Also, we're going to have the section cut of the, for instance, TNT in this case. As you can see, how TNT develops in our Eulerian domain. This is for model 1 and this one is for model 2. And also we're going to have the same thing for soil. As you can see, the explosion happened and these explosion waves move the soil up, and then it goes reach to the air domain here. And same thing with model 2. As you can see, the explosion happened in the border and the soil is moving to the both side, and finally when the explosion waves reach to the our beam, we're going to have a very big deformation here. And also same thing, the air plot, as you can see, this is for model 1 and this one is for model 2. Okay, so for this tutorial, what you need, you should know about the equation of the state, Johnson-Cook damage model, and also you need to have dedicated enough time for this specific example. Myself I spent I think around 7 hours to find to design this example and make it work and to get a meaningful result. And I don't expect you to spend the 7 hours, but I expect you to dedicate a good time to understand each part. You may not get it done first time correctly, but like I think at least you need the 2 hours. So if you have enough time and if you're ready, let's do this one in Abaqus. So now in Abaqus, I'm going to show you how to simulate explosion on an underground pipe. I decided to divide this tutorial into 2 parts because it's going to be very long. And in the first part, I'm gonna model. I'm gonna do a part property assembly step interaction, and in part 2, I'm gonna do a load mesh job, and also I'm gonna show you the result. Okay, so let's start by modeling our geometry. So go to the part section, and for here type domain, and it's going to be 3D, and this is going to be Eulerian and approximate size 12. So 12, which means that is a meter, so everything that I put here is a meter unit. Click on it, okay, and then create 2 construction lines, one from here to here, one from here to here, and then select this one, select on fix, select both of them, okay, and then click on rectangle, draw one big rectangle from here to here, and then give a dimension to it. So from here to here is going to be 6 meter, from here to here is going to be 12 meter, from here to here 6 meter, and from here to here 12 meter. And then cancel the dimension, click on done, and then depth is going to be 12. So we have a domain like a cube, and the length of the cube is 12 meter. Now I'm gonna go to model air. So air is going to be at the top of this domain, so it's going to locate it at the top, and we're going to have a soil at the bottom. So I'm going to say air, and it's going to be 3D deformable solid, and keep this one as 12 and extrusion. Click on continue, and then again draw these construction lines in the middle, fix them, and then draw a rectangle just only at the top. And then what you can do, you can select the coincident, select this point and this line, and then what I'm gonna do, I'm gonna give a dimension from here to here. It should be 6 meter, from here to here 12 meter, and from here to here should be 6 meter. Cancel the dimension, click on done, and the depth of it again is going to be 12, so it's going to be exactly half of the our domain. And next is going to be soil, 3D deformable solid. Again, same thing. I'm going to do exactly the same thing. The difference is that I'm going to have the sketch at the bottom this time. So I'm going to fix this one, and then I'm going to draw a rectangle from here to here, and then this one going to go on this, and then 1 point and the line 6, from here to here 12, and then from here to here 6. So now we're going to have another circle here in the middle. I'm going to draw it here, and the dimension of these is going to be 0.5. And what I'm going to do, I'm going to give a dimension from here to here, should be 2 meter. So basically this is the location of the pipe. So pipe is going to located in that area. So now click on cancel dimension, click on done, and then it's going to be 12 meter depth. Next is going to be a pipe. So pipe 3D deformable is going to be shell extrusion, and make this approximate size 0. Let's make it 1, and draw a circle from the center point here, and then give a dimension to it. The radius is 0.5. Cancel a dimension, click on OK, and the depth is going to be 12 again. So now I'm going to just double check what I gave to the depth of this one. Yeah, it's 12. So now the last one is going to be TNT. So it's 3D deformable solid extrusion, and again this one is good enough. Click on continue, and then draw these construction lines again, and then what I'm gonna do, I'm gonna fix these one, and I'm gonna draw a rectangle like this. So from here to here is 0.3, from here to here 0.6, from here to here 0.3, and from here to here 0.6. And cancel a dimension, click on done, and the depth is going to be 0.6. So we're going to have a cube with a length of 0.6, and as I explained to you before, if you do the calculation by timesing a volume to density, we're going to have the mass of TNT, which is around 363 kilograms, so it's a very big amount. So now we have the TNT as well. In the next step, I'm going to create a material property for each section. So let's start with the steel one. So steel is going to be for a pipe, and first thing, density 7850, mechanical elasticity, and this is 2E9, this is 0.3, and then from mechanical, go to plasticity, plastic, select the Johnson-Cook damage model, and then download this Excel file. Go to Still tab and find this one ST37. Copy this one and paste it here, and this is going to be 1, this is 1800, this is 293, and then I'm going to add a rate dependent data as well with the Johnson-Cook. So this is 0.017, this is 1, click on OK. Then I'm going to add the damage as well, a damage for ductile damage, Johnson-Cook damage model. And then I'm going to add all this data from here, copy and paste it here. And this is 1800, 293, and this is 1. And also I'm going to add a damage evaluation as well for this one. And it's going to be energy, and this is 400. And then click on OK. So now we have everything for still. Click on OK. Then go to pipe, and then from here select this one, say still, and then it's going to be shell homogeneous, continue, and then from here give a thickness to this one 0.01, which is 10 millimeter, and materials is steel, and then click on OK. Then assign this one to here, click on done, and then instead of definition, change this one top surface. So what we want the extrusion toward inward, and I'm going to show you how to check that. So click on OK, and then if I go to view part display option, and if I render a thickness, you see that I have this one. If I click on the surface, the outside surface is selected. So as you can see, I cannot select anything inside, which means that the extrusion was correct, because we don't want our shell body goes inside the Illyrian part, which we're going to have an error in that case. So now we are done with the pipe. Then I'm going to do a TNT. So for a TNT, I'm going to add the density first, which is going to be 1650, and then what I'm going to do, I'm going to add the equation of the state. Model is going to be JWL, and then I'm going to go to here, Excel file EOS, and then I'm going to copy all these parameter constants, paste it here, and this one 6E6, this is 0, and then for this one, detonation points, make everything 0. This one 0, click on OK, and this one OK as well. Then I'm gonna make a section for it, TNT, click on continue. Oh, sorry, so we're gonna create a section with a solid section, not shell. So it's going to be a TNT, homogeneous, continue, and select the TNT here and assign it to TNT, and then done. And now I'm gonna create a material property for air as well. So now this time it's going to be air, and then go to density, and then open the Excel file again, go to EOS, and if we go at the bottom here, we have the air, and then the density is very small, it's literally 1.22 something, so I round it up to 1.23, and then I'm going to add a mechanical EOS, and then we need to give a gas constant, and actually this is a pressure, which is going to be 1 bar, and so we have this data here as well. Unit for gas constant is joule divided by kilogram times Kelvin, so I'm going to paste it here. And also, what else we need for this one? We need a specific heat and dynamic viscosity. So I'm going to first copy this one and go from here, mechanical viscosity. I'm going to add this one. And then from thermal, specific heat I'm going to add this one as well. You don't have to add it, but it's better to add it. It would give you more data. So now I'm going to go here, find this one, copy it, paste it here, and then we are done with this. Click on OK. Create a section for air, solid, homogeneous, continue, select air, OK, and then go here and assign this air to this one. Okay, and now finally soil. So this is going to be soil, general density, and then again go to the Excel file, find the soil here. Actually I found a different way of simulating soil. So there are some people, they do use the EOS, like equation of the state, that you can use basically these parameters. Or there's another way that I'm going to do it here, because we have already done this and it's very easy. So I'm going to do this part so you learn something new in this tutorial as well. So first thing is going to be a density that is it at the end here. Copy this one, paste it here, and then go to elasticity, elastic. We need to add a Young modulus and Poisson ratio. So it's going to be these two. And then we're going to add a plastic behavior as well by using Moore-Coulomb plasticity. And this here we need to give a friction angle, which is 24, and this one dilation angle 0.12. And then we have a cohesion yield stress. So I think that's around, yes, is around 100 kilopascal, 0. And then click on OK. Create a section for this one, soil, homogeneous, continue, select the soil, and assign this one to this. Okay, so we are done with this. Now finally the Eulerian part. So I'm going to go to domain, select this one. This is going to be our domain, and I'm going to select the Eulerian one, continue. So now here we need to add all the materials that we're going to have in the Eulerian part. So the first one is going to be air, and you need to just press enter. We're going to have soil, enter, and also TNT, and click on continue. And then assign this one to this model. So basically our Eulerian domain has all three materials, but the location of the material is not in the correct place. Okay, we're gonna do that, assign a material in a correct section in a load section, so which is going to be the second part of this tutorial. Okay, so now we are done with the property. Now I'm gonna go to assembly. So in assembly, first I'm going to add a pipe, click on OK, and then, so here I'm going to use another method, because to move the geometry is going to be slightly different, but you can use the old method that I was using in the previous tutorial as well. So what I'm going to do here, I'm going to create 2 points, 1 point here, 1 point there. And then I'm going to say transfer this and transfer this point to the point 0, 0, 0. So if you remember, in the previous method that I was using, I was always putting the first coordinate 0, 0, 0, and then after that I was giving like a movement to it. But here I'm using the first point, and then after that transferring that point to the point 0, 0, 0. Now I'm going to add a domain, click on OK, and then as you can see, this is going to be here exactly in the middle. So what I need to do, I want to move this one first of all to the Z direction, which is right side, and also I'm going to move it slightly up as well. So what I'm going to do, I'm going to click on this. So I'm going to again use the new method for this one as well. So what I'm going to do, I'm going to select 1 point here, 1 point here, and then another point here, another point here, and then this point and this point, and then I'm going to click on this one, and I'm going to transfer transfer this point that I created to point 0, 0, 0. So as you can see, it's exactly located in the middle. Click on OK. And then I'm going to move this one 2 meters up. So select this one. And this is the old method that I was using in the previous tutorial. So I'll make the first one 0 and the second one 0 to 0. Click on OK and done. So now we have the location of the domain and also pipe. So I'm going to hide the body so we can see everything here. Next step, I'm going to add a soil. So soil activate auto offset. So we're going to have it here in the corner and then use this create constraints. Select this point and this point here. And then I'm going to bring air as well. Then I'm going to use this point and this point. Now the next part is going to be TNT. So for TNT, deactivate this auto offset because it's going to be already in the middle here. So click on OK and then go here, cancel this one by going to cell, cancel this, and then cancel this one as well. And then we can select that one. So I'm gonna what I'm gonna do, I'm gonna select this one, click on enter. First one 0, 0, 0. The second one is going to be 0, 0 minus 0 0.3. So as you can see, TNT is located exactly in the middle. So for this tutorial, for this specific, we're going to run two models. One model, TNT is going to be exactly in the middle, and the second model, the TNT is going to be between a border, like in the border between air and soil. So it's going to, half of it's going to be inside the soil, half of it in the air. But at the moment, I'm not going to do any modification for the second part, second model. We're going to do that in part 2 of this tutorial. That I'm going to get a copy of this, so we don't have to repeat everything. So we're going to have everything complete here, and then we're going to get a new copy and move that one up. Okay. So now I'm done with the assembly as well. I think I added everything. Let me just check from assembly. So we have 5 files. Yeah, that's correct. Now I'm gonna go to step to create a select a solver. So it's going to be a step, explicit, continue. For a time, I ran one model with a 0.05, and it takes very long time to do it. And like with 0.2, you're gonna get enough data to see the simulation. And if you just want to learn this tutorial, I'll suggest you to keep it as 0.02. But the file that I'm gonna show you, the time is 0.5, so I'm gonna keep this one as a 0.05, and then click on OK. And then I'm gonna go here, field output, edit this one. Increase the interval to 200 to have a nice frames and more frames and nice animation. And from failure, activate damage initiation criteria. And then also from volume, activate this one, element volume, so we can see element volume as well. And this one, EVF, is already activated, which is a material volume fraction in elements. And then we can only see this one in Eulerian, our Eulerian domain. And then I'm going to activate also the status as well. If we have any damage, the element would be removed. And also I'm going to activate this one as well, which is volume average material density. Again, we're going to only see this one in Eulerian domain. So now click on OK, dismiss this one. Then I'm going to go to interaction. Here I'm going to only create a general contact, so it's going to be initial general contact, continue, and then I'm going to select I'm going to create a new property for it, and then I'm not going to add anything here. I'm going to keep it as a default. Click on OK, select this one, OK, and yeah, that's everything for interaction. Now in the next step, I'm going to do a load, which is going to be the second part of this tutorial. Thank you so much for watching the first part. I'm waiting for you in the second part.